So welcome everybody to the AR/VR for training and education. This face talking at you is Tim. I'll do a quick little introduction in just a moment when we get to that slide. Andy's joining me as well. We'll be organizing a few of these events. We're really excited. This group, it's relatively new. This is the second event ever. Well, for the Bay Area group, that is. This is the first event for some of the other ones. I mean, we have people joining us from Boston and people joining us from Austin. And so we have a few different communities growing here. So either way, you're in the right place. If you're here for AR/VR for training and education, the Meetup Group, you are in the right place. So let's go ahead and get started. So what are we going to be doing today? Well, we always kick off with a few slides just to give everybody the context, a little bit of background on the group. So we'll start with just a brief introduction to the group itself. Then we have Ansinn diving into some of the real world uses of AR and VR on a production level, professional level, or professional grade standpoint. So we'll dive into a quick presentation there as it pertains to healthcare. And then You-Jin is doing some really awesome research around quote unquote world making in AR and VR. So using holographic technologies and projection mapping to build out worlds. So moving us away from only headset use cases in that case. And then lastly is the networking component. And I hesitate to use the word networking because sometimes it's a little bit of a dirty word. However, one of the goals for this group is always to leave with new friends and new professional acquaintances. And we found that the Zoom feature, the breakout rooms, is a really effective tool to get that. So we'll finish up with some of the breakout rooms as well. Those are just small groups. We'll talk about those in just a second. But again, this is the four parts for today. So what's really awesome is we see a few familiar faces and a few familiar names, and they joined us for the last session. So for those of you who joined us in the first session, big welcome back. But the majority of the people here today are just joining us for the first time. So for all of you, big welcome to AR/VR for training and education. What's our mission here? What are we been doing? Well, Andy and I started the group just to build a community of knowledge sharing. So we are all a bunch of instructional designers or knowledge sharing and learning sharing enthusiasts, and many of us are XR, so AR, VR, MR enthusiasts as well. So we're all coming together. We're bridging gaps between the XR world and then other peripheral industries as well, and cross-pollinating. So really cultivating a community of sharing information so that we can find ways to use XR tech in all the other peripheral industries, and then vice versa. Teach all of these other communities within those industries about XR. So how are we doing that? Well, we have fireside chats today. It'll be about presentations. Occasionally we do webinars. We'll do a few podcasts as well when we figure out how we organize that virtually, of course. Some workshops. There are quite a few of us who are excited about actually building this stuff themselves. So we will be offering workshops and some design and development jams as well. But fundamentally, this is just about cultivating community and growing your network so we can continue to meet new people, other people, enthusiastic people. So quick introduction. Again, my name is Tim. I'm the director of design and co-founder of Kairos XR, which is a consultancy or an XR consultancy and development agency. So we focus on building occupational training content, virtual reality, augmented reality, but also desktop 3D as well. And Andy, I'll kick it over to you for a little self-intro there.
Yeah, hi. Thanks, Tim. I'm Andy. I'm the director of technology and the other co-founder here at Kairos XR. And as Tim mentioned, we are just excited to create an environment where we can, all come together and benefit from each other's collective knowledge and have that networking capabilities, even though everyone's remote. So, yeah, pass it back to you, Tim.
Cool. And I didn't, typically with the agenda slide, I say typically, as if we've run so many of these. We've only run one. But the idea there on the agenda slide is we do clarify that virtual networking can be a little cumbersome. So I do want to make the point, if you come to these events, you just want to learn a few things, you prefer to be more of a fly on the wall and just observe, that is totally fine. And if you're somebody who's super excited to meet other people and you do want to engage in conversation, that's awesome as well, because that's what this was designed for. So regardless of your comfort level, we have some stuff for you here today. But the point being is that this is a very informal group. This isn't a big webinar. If anybody has any questions, feel free to hop in. You can turn on your mic. You can just use the chat as well to introduce yourself. The point being is that this is a resource for you. So by all means, do whatever makes you comfortable. So again, I mentioned KXR. We just mentioned KXR. We focus on building occupational training content. And the reason why we're here for XR and healthcare is because there are so many use cases. Again, I'm just going to set the foundation for discussing in just a few areas in which XR can be applied for healthcare. But we see it with hardware and software overviews. We see it with software interface training. We see radiology. We see pain management, physical therapy as well. Quite a few of these use cases we've worked on directly. Det's going to speak to a few of these use cases as well, which we're super excited for. But the point being is that these are, let's just see, these are just 12 use cases. Yes, I can count. These are 12 use cases. And effectively everything that you can imagine has been explored in some capacity. So there's no shortage of scenarios that we can discuss and examine and analyze, which is, again, what this group is here for. And ultimately, all positions can benefit from real world experience. And that's ultimately the primary value of immersive experiential technologies, whether it's an HR position or it's maintenance and operations on a machine, and then everything in between. We see this touching every industry in pretty much every position. So today is all about healthcare. Future events may be about accident prevention on oil rigs or solar installation in the field, or perhaps crane, as we see here, crane operations. So we will be touching all these different areas. But today, we're talking about healthcare. So Andy, I'm going to pass it over to you, given that you and Det have a personal relationship and professional relationship. So go ahead and make that intro.
Yeah, thanks, Tim. I'm really thrilled about today's presenters. So the first one we have here today is going to be Det Ansinn. A quick intro for Det is that he's a serial entrepreneur. He's the owner of Bricksimple in Philadelphia, or headquartered in Philadelphia. And they are a mobile wearable IoT development studio. Some of his work has been featured on Engadget, TechCrunch, VentureBeat, MTV, NBC News, Reuters, BBC, just to name a few. He's been featured in the award-winning documentary De Tuna, Portrait of America. And he also served as a member of the White House Business Council under President Obama. So Det, we are very excited to have you here today. And Det will be discussing the real-world use of AR and VR in healthcare. And so with that, we will relinquish the screen sharing and pass it over to you, Det.
Great. Thank you, Andy. All right, that worked, right?
Oh yeah.
Look at that. Great start then. Andy, thank you for the kind introduction, and both Tim and Andy for the work that you guys do. It's a pleasure to present and participate today. I was going to share with you work that we've done at Bricksimple, and not just this kind of hypothetical prototyping type work. Everyone sees a lot of concepts of how virtual reality and augmented reality can radically change X. And it's just like basically a concept video and done. I wanted to share experience that we've had applying this technology to training in healthcare and also in the delivery of healthcare, leveraging AR and VR to improve patient outcomes through better training of the healthcare professionals that support them. And this kind of thinking can take place at all different types and levels of care. I wanted to start out with something big. And by big, I mean physically large. This is a proton therapy machine. Hopefully you've never had to experience one as a patient. It is used for cancer therapies and treatments. This particular machine is at Penn Medicine here in Philadelphia. These are incredible machines, and you can see around that circular section, there's this massive structure that follows it. These buildings that house these machines, these are machines alone that are in the tens of millions of dollars. The buildings are can be in the hundreds of millions that house these facilities. They're massive, but have a huge impact to patient care. The challenge that they're used more or less constantly, demand, and there's not enough of these machines to treat, the demand of patients. And having time to work with the machines can be very difficult. This isn't something that an augmented reality solution will help you with, because trying to get access to the machine, and there's no real, physical way to take something this big and make it work in a practical scale. So we work with Penn Medicine to create a virtual reality, a high fidelity virtual reality experience that took you through the operation of these machines, completely through the operation. You set things up for a patient, all the procedures that you go through, and match the scale of the machine as they exist in these facilities, that someone who goes to this training experience can walk into that space basically having been there before within the virtual reality experience. So we really went to great lengths for the fidelity experience, even the patient transition areas, control rooms, all these aspects to realize them and make this happen within virtual reality. And when you take an experience like this to make it not just visually pleasant, but the fact that it incorporates all these various elements that you can actually go in and operate the key machine functions, this is a big deal. It delivers, allows you to do training on something that would otherwise interfere with delivery of care to patients, and done on a grand scale. That's obviously one end of the spectrum. The other end is for, someone working with a patient, a nurse working with a patient, to understand practices and procedures in that care. And we worked with Children's Hospital of Philadelphia to develop a platform that enables them to use mobile class virtual reality, i.e. Oculus Quest or Lenovo devices, to use these devices to reinforce for new nurses in working in the facility the CHOP practices for working with patients. So it orients them on the kinds of things they see through the equipment, the kinds of various procedures that they go through, and takes them through each of these aspects in a way that's safe and very important in the current environment that exists, that because this is to be supported by a mobile class VR device, they can literally take that Oculus Quest in the bag and they can be given that, and they can work from home or wherever without it being in the care facility, to understand the layout of the rooms, how these things are set up. And nurses who are tremendous professionals and having that information, having a heads up on what to expect when you're in the facility and the practices and expectation is a really big deal. And what we like about nursing use cases at Bricksimple is that surgical use cases are interesting, and maybe they're, if this healthcare facility has a few hundred, doctors and surgeons, but there are thousands of nurses in these facilities, and the scale, the impact that you can have with nursing use cases is a big deal. And we're always looking at ways to improve that experience, to elevate how they can do their work and focus on patient and quality of care. Now, when using virtual reality, sometimes an education process just isn't about someone understanding specific procedures, understanding how to, operate machine X, go through this standard and practice, understanding that. Sometimes it's about empathy. And when you think about the different types of training, whether you're looking at a screen or a video and going through that process, to have empathy with what a patient's going through can be really challenging. And virtual reality offers a unique opportunity to put someone in the experience of the patient so the caregivers better understand how to care for the patient. And in this example here, you see the gentleman there wearing the HCC Vive. He's also wearing a weighted vest, and he's wearing weighted track gloves. The design of this particular experience is to give the person some of the symptoms within virtual reality of what it's like to have hyperphosphastasia. It thrusts them into a care scenario here in a care center, and takes them through activities like even lifting up a milk carton. You see a tracker on there. That milk carton is heavily weighted, so when they go to lift up that carton in the VR experience, they feel weight. And we give them physical objects to interact with the experience along with the visual cues to make something that's very credible. And we've done a number of these empathy experiences. And another example that we had gone through, project we worked on, is we had to get other factors like blurred vision and even causing people to stutter. one of the symptoms is stuttering, this other disease state we work with. And we did that by actually doing a closed loop delay of their own speech by a couple hundred milliseconds to trick them into stuttering. There's a lot that you can do with this kind of experience where you can really connect folks and do things that you can't necessarily convey through watching a YouTube video or taking another kind of experience, that you can leverage all these pieces to do things in virtual reality that can't be effectively communicated. And we're trying to build empathy for patients in care, whether they have ALS, whether they have hyperphosphastasia, or these other disease states. It's something, an area that we, when going in, building these VR experiences within healthcare and training, not an aspect that we expected, was very interesting and important to understand what a patient's going through. One of the things that I've seen as we've worked on these kinds of experiences and training tools is that there's no substitute for physical interaction. That you can have the vibrating motor haptic feedback, you can have those elements, but there's no substitute for the physical aspect. And we had been working with mannequins in virtual reality scenarios and augmented and mixed reality. Obviously, it's helpful to have something there in the real world, but to tie all these things in together. In this case, this is an award-winning CPR training experience we did using the Microsoft HoloLens that ties in with sensor data in the mannequin to help with CPR instruction. And you think about the impact that these things can have when you're combining those physical elements and these cutting edge visuals to bring it all together to have a very impactful training experience. So extending that from something more basic like CPR to actual nurses treating patients. In this case, treating sepsis in pediatric patients, which is very challenging. There's been other various training mechanisms trying to get nursing personnel to understand what's required to treat these patients. And when you're treating a patient septic shock, it involves the careful injection of fluid into the patient experiencing the shock to go and bring about, a stabilization of that shock and bring them forward in care. And these solutions are applied very carefully. And with a small child, you have to be extraordinarily careful in terms of how you apply this fluid for the child. So what we had done is we had worked here with CHOP to use a sensor within the mannequin, which coincidentally is a Keurig coffee machine flow sensor, to measure that fluid as it goes into the patient and give them a visual response to what's happening inside the patient while they're going through this. So here you see animation outside of that where we actually show the impact as they're using the syringe, and they can see directly the impact of their actions and gain a better feel for it. This particular application right now is going through a clinical study to measure its effectiveness in training. We've done a lot of work where when you're working in medicine, it's not just a matter of it looking cool. It has to really work, and that really work is you measure it. You do studies, you do these things to see how effective these solutions can be. And this solution, preliminarily with the studies, has been tremendous. And the idea that we can take this and have this used across, many different mannequins, the parts required to augment the mannequin for this type of use are extraordinarily inexpensive, but the impact is huge. Being able to have this run through a HoloLens or other device and be able to have the visualization is really a big deal. But we've talked about that large scale. We've talked about nurses and patients and mixes of VR and augmented reality. I want to bring us to an example here of using this technology in much smaller scale. And by smaller scale, using augmented reality to replace what you see here is a surgical microscope, to take that surgical microscope and replace it with a wearable smart glass device that provides an augmented view of a surgical site. Here you see an example here being used by Penn Vets to evaluate it. This would replace that big, bulky 700-pound surgical microscope, which what you see there in terms of two stereoscopic 3D cameras on an arm. Here's another shot of it in action. When you're doing things where you're putting smart glasses and these augmented reality displays on surgeons, on folks who are working with a patient who may be receiving telemedicine support, it's a big deal. And we've gone from this, ugly working prototype, as we call it, to now an evolution of a smaller working prototype. It's actually powered by NVIDIA's Xavier, because we're leveraging artificial intelligence elements of something that can be battery powered and carried up a hill. Obviously, military has strong interest in this, in nations with less developed healthcare systems. To bring this technology, ability to have a surgical microscope in the field is a big deal. And looking at this in ways that prior ways these technologies have been used, in terms of loops and these other simple devices, we're looking at ways how we can leverage this hardware to, really provide a different kind of care, different level of care, and also ease the burden on doctors and surgeons and other folks who are working with patients. And in doing that, one of those burdens that we've eased is this whole manner of managing the inventory of the various instruments and tools used to treat a patient. So we're using object recognition combined with other tracking tools, so we can track the number of pieces of gauze that may go into a patient, to track them coming out. We track the tools that have been used and not used, the tools that require, instruments that require sterilization. Bringing together all these elements for something, when you have smart glasses on the head of a doctor or surgeon, really opens up the possibilities. And we're excited about how this is currently being used now, where we can further expand it. We're building a much greater library of instruments to further power the solution. Now, we've spent a lot of time talking about wearable AR, or VR wearables. I wanted to share some work we've been doing with the Looking Glass technology, which is a 3D volumetric display. And we've actually created training and educational experiences using these devices that allow you a 3D interactive visualization, where you can go and interact with these elements, bring it together, and do it in a way that doesn't require a display. You see there's a finger goes over, we can select elements, not quite at stock video territory, but leveraging this in a way that's not just what someone's wearing on their head or holding up a computer, but be able to do this in a 3D volumetric fashion. So I wanted to share these things because these are things that we've out there, they're in production, it's not conceptual. But I wanted to share these experiences to give folks a flavor and hopefully inspire with the types of solutions that are available. My contact information is here. If anyone has any questions, I'm happy to entertain them. I hope I didn't run too long, Andy and Tim. But hope also that I was able to give some cool stuff for you guys to see. So thank you.
Yeah, awesome, Det. That was fantastic. We have a few minutes here. Would love to open it up for questions. I see a few coming in the chat regarding access to decks or this recording. We'll go ahead and take those offline and just double check with everyone, make sure that that would be appropriate. The best thing you can do if you're interested in staying in touch with Det or interested in reaching out about some of the content that he's produced is to join the email list. We do have an email list, which is a great place to network with everyone in the meetup here. So we will share a link to that. Would love to have you volunteer your email there if you're willing to chat with other individuals in the network here. Beyond that, we had a few questions that were submitted prior to the session today. So I'm going to go ahead and ask those. But if you have additional questions, feel free to drop them in the chat. Det, one of the questions that we had was, what challenges have you faced with device management for clients, knowing that running multiple devices can be quite challenging? Curious what your take is on it.
Device management has been a challenge. We're starting to see the real good, useful first-party solutions, even from Oculus, which traditionally had been terrible with that. We had previously worked with Augmate, which is they're now defunct, but they had an MDM product that we were able to leverage. Walmart was an Augmate customer, among others, to deal with scale. Device management, what's nice with this enterprise focus, certainly Microsoft and HoloLens have been way ahead on that, but HTC, Oculus, Microsoft, Magic Leap are all taking that aspect seriously now. You can't say you're to focus enterprise solutions without having a solution in that space.
Right. Nice. And, let us know if that's something that you folks are interested in learning more about. We'd love to, have a meetup specifically on that topic because it does deserve its own kind of space. It's a big topic. Another question that's come in here in the chat just now. So how effective have these XR trainings been compared with the more traditional ways of training? Curious if you can provide any insights into that comparison.
We did a VR training experience for CPR. That was a subject of 3 separate published studies. And we saw a 70% improvement in skills retention doing CPR and VR versus other methods. And also this much greater confidence in those who are trained that the skills were sticking. I mean, it's one thing to sit there in a classroom, we work with Recessa Annie. It's another to be thrust into a situation and where your skills are required and the environment feels like it. The one I mentioned with the CPR VR experience, that one we had, we used a Laerdal mannequin, but the rendered experience itself was a urban streetscape. So subjects for the study were thrust into a scenario where someone has a cardiac arrest in the streetscape experience. They then perform CPR, they call upon their skills and do that, and have it be in a much higher tension fashion than just being there with a mannequin on a table or on the ground. It also allowed the subjects to ask for help. We used natural language processing and voice recognition that they could tell people to call 911, get me an AED, do these things, help. And within the study experience, we actually had these NPC characters. Some of them were very helpful, responsive, and others weren't. So really trying to create an authentic experience to make it work.
Great. Very, very insightful. We have time for one more question here. So I'm just going to take the next one that is in the queue. So are medical providers typically willing to introduce XR into the operating room? And have you received any pushback from bringing these devices into the operating room?
There's different aspects, understanding that there's points where you cross over where you're a medical device. And certainly in research context, there are different, flexibilities they have. But I think a lot of folks working in the space tend to underestimate the challenges there. And give you one example is that, I've seen a lot of these conceptual pieces is sterilization issues. How are you sterilizing that device? There are some real basics where things fall down. I think there's a lot of enthusiasm for these devices, and we're in the process with several of the products that we're helping develop right now. We're in the process of going through FDA approval for some of these things required. I think the enthusiasm is there, but we also see opportunities that are popping up as a result of sensitivities around COVID-19, concerns around infection. I think that they're open to it. The trick is, if you're working in this space, is you have to be measured. Do not be flippant with, how you can bring solutions into these areas. I mean, you just can't go and take a HoloLens and put it on the head of a doctor who's working with a human. There are other aspects to this that are a bit more complex, demanding. That's one of the reasons why training has been such an area to lead on that, because training does not have these same kinds of regulatory burdens that you have. It still has to be effective, still has to be measured, but doesn't have the same kind of regulatory burdens as something in the operating room.
Awesome. Great. So we do want to save some time for our next presenter, but Det, really, really appreciate you taking the time to present and going through those questions. We are going to be recording the additional questions here, and we will do our best to address those. Again, the way that you can stay in touch here would be to sign up for that email list. It's going to be the best way to stay in touch. But we are planning on providing some follow-up blog posts where we dive into more depth in some of these questions that are coming in. So continue to add them.
Thank you so much, Andy. Thank you, Tim. And I'm looking forward to hearing you speak. So I'm just going to mute myself now.
All right. Great. So transitioning to our next presenter. Our next presenter is You-Jin Kim. He is going to be discussing some of the cutting edge research that is happening at UCSB. So we're going to be transitioning for some of those real world use cases to seeing how some of this research that's happening in the academic world is going to be supporting those real world use cases. So You-Jin Kim is a mixed reality researcher at the Four Eyes Lab in University of California, Santa Barbara. He is developing a unique spatial augmented reality system where users can freely interact with the computational space. He will be discussing his current research on world making in AR and VR environments for human experience research. So with that, You-Jin, I will pass it over to you. We will relinquish the screen sharing and feel free to take it away.
Just 1 second.
And while You-Jin's setting up here, feel free to drop the questions in as he's presenting. That way when we get to the Q&A section, we'll be able to just have those queued up. So feel free to just continue to drop the questions in. We appreciate the interaction and engagement. You know, the goal of this session is to get all those questions answered, so keep them flowing.
All right. Can you guys see?
Yep, you are coming in loud and clear and can see your screen.
All right, good. Hey guys, this is my honor to talk to you guys. I would like to share some of the FOB research that we are doing at the Four Eyes Lab and the Microsoft Perception and Interaction Group. And please do ask right away because I don't want to just like go tangent on my research as we mostly do. And it's a little word heavy, so I will show you guys the video first. So this is a what's called perception distortion room. And this is in the Microsoft Research headquarters at Redmond, Building 99. And it uses a 6 projector. And we do dynamic projection mapping. And what the dynamic projection mapping does is that it uses a player one head coordination and all the joints to track and adjust their perception and peripheral vision so that whatever they're feeling or like seeing is correct to the game environment itself. So a lot of time when it comes to augmented reality, there was a problem with limitation of the physical room. Anything that we project cannot be outside of the physical room. But because the system tracks their head coordination and the position, you can provide a correct vision, FOV vision to one player. But the beauty is that it could support up to a like 14 HoloLens, and currently it can support up to 2 a Vive headset to correct that preferred vision for multi players. And so the objective is that it will allow multiplayer in a same interactive room without crashing each other, because we do manipulate the room distortion to make sure that every time there's a room distortion, people will move away from certain location, making space for the other movement that could be happened, and it could be a lot more safer. And this redirective study is done at the Microsoft, but we did continue to do the user study, about 40 user study about 480 hours. That's quite a substantial amount. And everybody in our lab got certified by the University of California Human Research certificate to make sure that um, we are not doing harm to people when we are doing extensive research as such. And so for a healthcare, I do believe that it could improve in 4 major points, and it could project something that is bigger than the physical room itself on projection mapped environment. So that's the first point. And the second point is that it can simulate an emergency room size. It could simulate like the emergency situation in that room. So we can actually play the game. So I actually uh, learned about Andy's project by reaching out because of the Unity Technology AR workshop. And from there, we were at Microsoft, we were able to actually put a whole playable game into that room. What that means is that we tried out with many like pretty famous games such as like Gran Turismo, like GTA, like not a good games, but like kind of like the popular games that's out there. And we were able to actually run that in that AR immersion room with multiple players. So that proves us that it's not only playable, but it could be played in a many players. But the fact that it can play the whole game in that room, meaning that it can really simulate any kind of situation that's fully interactable. So we do tracks, we do track the joint of the hand. What that means is that it have a possibility. We haven't used that yet, but we have the possibility to simulate the hand coordination. So it could be a lot more detail, and not only that, it tracks all users up to 12. So that's a quite a limitation we pushed at Microsoft. Like that was possible because we do use the 8 Kinect on that room. What that means is that it does have an 8 point that collects that joints point. And as I said, it does provide a bigger FOV to the current HoloLens, because as you may already know, the HoloLens have a very big limitation of the size of the field of view display. And a lot of time what we can do at the dynamic projection mapping is that it could expand that, kind of uplifting the limitation there. And multiplayer AR has a 3 big limitation. Of course, there's a physical limitation, like physical space limitation. You will run into the wall when you're immersed enough. So there needs to be redirectioning happening within the game, but without breaking immersion. That's probably like the biggest thing that we all know. And the second point is that on that projection dynamic mapped room, yes, it's interactive, but each FOV, the field of view, is unique to individual, because the moment that peripheral vision and field vision just is slightly off, human we find out. We did test out with quite a lot of human user study. Every time there was a lag, people would know. They were like, hey, something is not right. And that was interesting to us because we are using like a pretty much like industry standard RTX 280 Ti. We do use 2 of them right now to simulate all that. And sometimes with many users, it does overlay, and if there's a slight delay, people will find out. They're like, hey, something's not working. Like, I'm not seeing it correctly. And they're not shy to say that. And third limitation is a cross-eye limitation. So our brain understands anything that is too close to, so anything that we see in our hand, even though cross-eye happens, it's in our brain, it registers. But the problem with the augmented project object, anything that's too close, our brain knows. because we are seeing the defects of the augmented objects. So just like how the best example of this would be if you play a game and if you come to certain building or like certain object too closely, it just breaks and you go into the 3D object mesh. Like I'm sure some of you guys have experienced that. And that really do comes from the fact that there's a limitation of how much human can register in terms of how close it is. But that some of that could be corrected by our system where we can projection map. So a lot of that can be on the HoloLens, but anything that's too close that's gonna interfere with that, we just project to the specific spot so that it's more registerable. So you guys already know that it's a unique spatial augmented reality system. It really was meant to expand what currently have as an augmented reality plus dynamic projection mapping. And the beauty here is that everyone in the room get to experience, because all the peripheral vision is corrected of all time. But you guys may have a question saying, hey, if there's a 3 people in the room, wouldn't it break the illusion? Yes, it does, but that's why we have what's called a player one. So what player one is that anyone, the authority that we give would have a full experience, but other component who uses HoloLens be assisted so that it will look as if they're in the room and everything is peripherally corrected. But a lot of users did not even notice the fact that because most of our demo is using a grid line on the dark space, it's a lot more believable. So if the contents do get rich, it may breaks it, but as you may know, HoloLens technology, like holographic technology, is also evolving. So we expect that it's gonna be compensated by that. So this is the state of, so as you can see, we are using a 6 projection, including the bottom. So all the furnitures do get projected. That's how occlusion can happen. But with anything, the occlusion is tricky because anything that we project that's too light is gonna break it. So you have to use the occlusion with consideration. And this is some of the basic information. And I'm gonna show you guys just one more thing. So this is a live 3D environment at Unity engine. And as you can see, all this playable game spot this is live, by the way. So we made what's called a live mesh. What live mesh does is that if anyone goes in, it scans the 3D mesh, put it on, and then not only that, it has a fully it's actually all colored in and everything looks good, everything is interactable. Every joints point there is a Rigby, so like rigid body. What that does is that it's actually interactable. And some of the research we are doing next is implementing ML agent at Unity to understand how people use these, how people interact with these 3D space, and use that component to HCI interactable like controller. Think of it as like we understand how people interact with the room, and then it's gonna be used as a controller. So that's gonna be done with so we now have 480 hours of human interaction with the changing space. And then now we're gonna use that collected data to learn about what we can be used as a controller without having any physical like game controllers. So as I have explained, the 4 eyes that we are really trying to push the like limitation of field of view, but also to interact with many users in that one space. So a lot of research is being done, And the fact that we have collected all the human reaction data, we can move forward to implementing on the real simulated environment. Yeah, I don't know how relevant this is to the full medical conferences. But if you guys have any question about a multi-user interaction in one room, I'm here to answer your question.
Awesome. Awesome. Thank you, You-Jin. That was fantastic. It's really awesome to see what is being done in the research side and improving the immersion of augmented reality. So
Yeah,
I
I
think
try not to go to too engineering side, but it's a little difficult without going into too deep. So
totally,
I hope you
yeah. I
guys
know
understand.
how challenging it can be to take something very technical and boil it down. So definitely appreciate you walking through. We have time for one question. We had one question submitted before, but saw a question come in while you were chatting. So did want to get that one answered. So we have a question that says, connects Xbox connects to use dynamic mapping or using Azure's or the Xbox? How are you doing the dynamic mapping?
The dynamic mapping, we do use Azure server. So so all the devices that we use, the joints points is uploaded to Azure point cloud. So we share the vector3 format on each joints. So every time the new player comes in, there's gonna be a hierarchy of whose joint points is going to be referred to as in comparison to the other user players. But it's very simple way of uploading a cloud joints, because what we are using right now is a Kinect 3. So 8 Kinect 3 is used, but the fact that it's 120 frame, but the fact that it uses that 60 frame to scan, it can only, it has a fresh rate of 60 frame per second. So anything like speed intense is gonna be little bit, yeah. So you do understand? Okay.
A little bit delayed. All right. Great, great. So we do have a few additional questions. I'm going to direct those to the email list. We do appreciate the questions. We'll try to get those answered either in a follow-up blog post or through some additional networking here. But we have gotten to the last 10 minutes of the presentation here. So I want to thank you again, You-Jin, for taking us through that. Very exciting to see what's happening on the research side. And then, at the same time, seeing what's happening, in production, right, in cutting edge healthcare solutions. So
Just one last question. I'm sorry. So to the, I'm so sorry. So the machine learning agent, we are using release number 3. To the whoever asked, we are using the June 10th machine learning number 3, release number 3.
Okay, awesome. Great. So hopefully I was able to address that question there. With that, again, thank you, You-Jin, and thank you, Det, for presenting today. We are going to continue on with some more networking. So I'll pass it back over to Tim, and he'll take us in.
Cool. Sounds good. Thanks, Andy. All right. So, guys, this is the next part of the session, kind of the last little chapter here for us. So before we hop into our virtual breakout rooms, wanted to throw a little more information at you guys in regards to some upcoming events as well. The next one, we have another event very similar to this, but Bill Mayer from the Virtual Science Center will be speaking to a few of their projects on July 1st, which is actually next week. We typically try to run these every few weeks, and in this case, we're going to have back-to-back, which is exciting. So 2 weeks after that, again, we'll have another virtual networking with XR Pros event. That will be themed. Chances are it won't be healthcare, given that we've had a few healthcare events now, but we will have, in the next few weeks, we'll have a few events. If you have any additional questions or comments, again, you do have the email doc now, so please stay in touch with that form, but you can email Andy or myself at tim@kairos or andy@kairosxr.com or connect with us on LinkedIn, as you can see in those bit.ly links. And the last bit here before we go into our virtual breakout rooms is we'd love to get some feedback. So we're always trying to make this as useful as possible for you, the community. So if there was a part of this event that you absolutely loved, or a part of this event that you would have liked to perhaps omit or move through in a different way, definitely let us know in that bit.ly link. So Andy, while I'm introducing the virtual breakout rooms, if you would, please go ahead and drop those links in. So what are virtual breakout rooms? So again, a lot of us are here so that we can meet other professionals and meet other people. Given that this is the end of the presentation, or rather it's towards the end of the session, this is just an hour long. The whole meetup is. Feel free to hop off if you'd like, but if you would like to meet a few more people, we will be breaking into rooms of about 2 to 4, actually 3 to 5. So that will facilitate certain conversation. You can introduce yourself as well. We provide a few prompts, kind of like icebreakers, but we'll spend about 5 to 10 minutes in each group so you actually get to know the other folks in the group, and then we'll reconvene and we'll flip it around, we'll mix it up a few times, and then we'll break into virtual rooms again. So we'll go, given that it's already 12:53 here, feel free, we'll hop in for about 5 minutes.